Section 6.1 is ratios and rates. I can find ratios. An archer shoots 60 arrows at a target, with 44 arrows hitting the scoring area and 16 missing the scoring area. How can we evaluate the archer's performance? We can compare the archer's number of hits to the archer's number of misses using a ratio. A ratio uses division to compare two quantities. We can write the ratio of two quantities, A and B, where B isn't 0, in three different ways. We can simply say A to B with words. We can do A colon B, or we can write it as a fraction. A to B. A over B is A to B. Each ratio is read the ratio of A to B, and should be always written in simplest form. Example 1, we're going to use archery information from the opening statement. Write the ratio in three ways. So we want the number of hits to the number of misses. And if we look back here, the number of hits was 44, 16 was misses, and there were 60 total. So 44 hits, 16 misses, and 60 total. The number of hits to misses, hits is 44, to misses, 16. Now, we need to write this ratio in three ways, and we need to remember to always have it in simplest form. So we're going to check and see if there's anything that goes into both of these. In class, they told me that we could take a 2 out of both, and then a 2 again, 11, and 4. So 11 to 4 is 1. We can also write that with a colon, 11 to 4, or as a fraction, 11 to 4. And again, this is hits to misses. Order is important. How about the number of hits to the number of shots? Well, the number of hits is 44 to the number of total shots, 60. Again, try and reduce this if we can. I can take a 2 out. I can take another 2 out. So 11 to 15. We can also write it as a colon. And we can write it as a fraction, 11 to 15. So sometimes it's easier to write it as a fraction first and then reduce it as a fraction. It's a little bit easier to see that. So if I would have written 44 over 60 first, instead of with words like over here, it's easier to reduce our fraction that way sometimes just by looking at it. Now, using the same information, compare the number of misses to the number of shots using the ratio. Write the ratio in three ways. Go ahead and pause here and give this a try. Okay, we want the number of misses to the number of shots, or the number of total. And on the top we said misses was 16, and the total was 60. So we can reduce this. I can take 2 out of both, and a 2 again, and I get 4 over 15, which is also the ratio of 4 to 15, which is the ratio of 4 misses to 15 total. So those are my three ways. To compare two ratios, we can write both ratios as fractions or as decimals. Two ratios are called equivalent ratios when they have the same value. So in example 2, the ratio comparing the length of a bird's wings to the average width of the bird's wings is called the bird's aspect ratio. We're going to order the birds in the table on page 240 from the greatest aspect ratio to the least. Again, remember that order matters, so we're comparing length to width. So length to width. Okay, and we have 3 birds. We have an eagle, a jay, and a gull. And again, all this information is on page 270. So for the eagle, the length is 209, and the width is 30. So we want the ratio of length to width, or the ratio of 209 to 30. This is our aspect ratio. The jay is 47 to 12. So our aspect ratio is 47 over 12. And the goal is 83 to 8. So our aspect ratio, we can say, is the ratio of length to width is 83 to 8. Now, if we look at those, it's not necessarily easiest to tell which one's smallest, which one's biggest. But if we write these all in a comparable form, like a decimal, we can see the ratios here in a comparable manner. So if we divide these here, we're going to get approximately 6.96 repeating. Here, if we take 47 divided by 12, we get 3.916 repeating. And here, if I divide, I get 10.375. So now we want to know what is the ratio from greatest to least. Well, greatest to least means that we have goal, then eagle, then J. Rates. A rate is a ratio of two quantities measured in different units. A unit rate is a rate that has a denominator of 1 when expressed in fraction form. Unit rates are often expressed using the word per. Example 3 here is finding a unit rate. You host a party for 12 people. The food and drinks for the party cost $66. What is the cost per person? Okay, so we want cost compared to people, cost per person. And per means unit rate, so we want our denominator to eventually be 1. First thing we're going to do is set it up, though. We want cost compared to people. And our cost is $66, and 12 is our number of people for 12 people. Okay, now we want the cost per person, so to get that we take 66 divided by 12. And when we do that, we are going to get $5.50 per one person. We can also rewrite that as $5.50 per person. Okay, so let's say you ordered a couple pizzas and got a case of Mountain Dew or something. It would get you to $5.50 per person. In example 4, a jet flies 540 miles per hour. Write its rate in miles per minute. Here we start off with 540 miles per hour. So it's 540 miles per 1 hour. And we're trying to go to miles per minute. So eventually we want it to be miles per minute. If we look here, guys, the miles part is the same, so we don't have to change that at all. The part that's different is hours to minutes. So I have to find a ratio that relates those two to be equivalent. So if you look on page 817 in your book, there's a page table of measures. So on page 817, this one I feel like we probably know. 60 minutes is the same as 1 hour. So I'm going to multiply it by that conversion factor. Here, if we look, I need minutes to be in the denominator in my final answer. So I'm going to put minutes in the denominator. I also need hours in the numerator so that I can cancel those out. One in the top and one in the bottom means I can cancel those out. Now, make sure you put your values with those. 60 goes with minutes and 1 goes with hours. Double check, I have miles in the top and minutes in the bottom, which is what I'm looking for. Perfect. So we multiply across in fractions. Okay, I get one big fraction. So 540 times 1 gives me 540, and that's miles, over 1 times 60, 60 minutes. But I don't want to know a rate here, guys. I want the unit rate because I want per minute. So I have to go ahead and divide those, and I will get 9 miles per minute. And those are equivalent. So we can either say 540 miles per hour or 9 miles per minute, and they mean the same thing. Engineers designed a miniature robot that can crawl through pipes and vents that humans can't access. The robot travels 1 inch in 3 seconds. How many feet does it travel in 4 minutes? So we're looking for 4 minutes. Okay, so we need to compare two things because inches and feet don't match up and neither do seconds and minutes. So there are 12 inches in 1 foot and 60 seconds in 1 minute. So we're going to actually multiply by 2 fractions here because we have to change 2 things. When we look, let's do inches first, it doesn't matter. I need feet to be in the top, so I'm going to put feet in the top. I also need inches in the bottom so that my inches, one in the top and one in the bottom, and those cancel. Then we plug in our numbers with those. 12 inches in 1 foot. Okay, I've accomplished my goal. I have feet in my numerator. Now I need to get rid of seconds. I have seconds in the bottom, so I need to have seconds in the top so that those cancel. And in my label, I need minutes in the bottom, so I need minutes to go in the bottom. 60 seconds are 1 minute. Okay, again, I need seconds to cancel. And I have minutes in the bottom. So my labels are right. We multiply our fraction straight across. 1 times 1 times 60 is 60 feet. In 3 times 12 times 1, 36 minutes. So to get our unit rate here, again, we're going to divide, and I get 1.67 feet per minute. And that's per 1 minute, but remember, we want 4. So to get 4 minutes, we just multiply by 4. And I'm going to get 6.67 feet per minute. Feel free to pause on these and try them. I'm going to work through them here. So we want to go from centimeters to minutes, centimeters per minute to centimeters per hour. So again, the centimeters part stays. The thing that changes is minutes and hours. And we know that it's 60 minutes in 1 hour. Guys, it's only set up like this. Don't let the way it's set up fool you. What they're saying is I have 5 centimeters over 1 minute, and I want it to go to some centimeters per hour is the final label that I want. So I need centimeters on top. I have centimeters on top. I need hours on the bottom. I also need minutes to cancel. So 60 minutes in 1 hour. Minutes and minutes. When I multiply across here, I get 300 centimeters per 1 hour. And I have centimeters per hour, so this is what I'm looking for. In number 3, I have 5 meters per 1 second, and I'm going to meters per hour. So again, we don't have to have just the number there. We're not trying to find that number necessarily right away. What we're trying to do is to get our final label to be meters per hour. So 5 meters over 1 second. To go from seconds to hours, we might not know that right away, but we know that there's 60 seconds in 1 minute and 60 minutes in 1 hour. So we set up 2 fractions to get us there, just like we did on the last one with 2 different measurements. Same idea here. I need seconds to cancel, and I need minutes on the bottom so that minutes can go on top and cancel and give me hours on the bottom. Minutes will completely cancel. Seconds will completely cancel, and all I have left is hours and meters. So 60 seconds in a minute, 60 minutes in an hour. Multiply and get 18,000 meters per hour, and that is section 6.1.